So this is your first video and set of notes. It's for the introduction to chapter 1, which is also an introduction to the study of statistics, as well as the first part of section 1.1. You'll notice that in your notes, all of section 1.1 is together, but there are going to be two separate videos for section 1.1. So to get us started, we want to talk a little bit about some important definitions so that when we use them moving forward, we're all on the same page as to what they mean. So we'll start by looking at what exactly the study of statistics is. So statistics is, in its most basic form, the science of data. So data is information that has been collected. So statistics involves collecting data, analyzing data, and making predictions from that data. Now in this course, we also study probability because that leads into helping us to make predictions for the data. So as we discuss data, we're going to be talking about the terms individuals and variables. So when we talk about individuals, what we're talking about is the objects that the data is describing. So these objects can be individuals, can be people, animals, or things. Okay, so these would be what we call individuals. Now from these individuals, the actual information that we collect is what we call a variable. So a variable is any characteristic of the individual that we're going to be studying. It can take on different values for different individuals. So for example, if we were talking about Columbus students and we wanted to learn about the hair color of Columbus students, our individuals would be the Columbus students because that's who we're interested in learning about. And the specific characteristic we want to learn is their hair color. So that hair color would then be considered the variable. Now, when we talk about variables, there are typically two groups that they fall into. The first is what we call categorical variables. And so these variables are variables that put our individuals into different categories or groups. So some examples would be things like hair color, gender, your area code, things of that nature. The other type of variable that we often study, and we'll spend most of our time looking at these, is what we call quantitative variables. So quantitative variables take on numerical values for which it makes sense to take an average. So what do I mean? I gave you an example in categorical variables of area code. Area code is a numerical value, however, it serves as a category. It describes a location, and people in that location fall into that category. It doesn't make sense to take an average of area codes. So area codes would not be considered quantitative. On the other hand, something like GPA or height or weight, we could take that same group of Columbus students and collect information on heights, and it would make sense for us to take an average of those heights. It would give us a piece of information regarding our Columbus students. Now, for our quantitative variables, there are typically two types of quantitative variables that are studied. The first would be what we call discrete variables. So discrete variables take on a fixed set of possible values with gaps in between the numbers. So for example, if we were counting the number of siblings someone has, the number of siblings someone has is in fact a quantitative variable, but it's discrete. You have either 0, 1, 2, 3, 4 siblings. They are specific fixed values with no possibility of being anything in between those fixed values. Now, the other type of quantitative variable that we often look at is what we call a continuous variable. And a continuous variable takes on any value in a given interval. So some examples of continuous variables include things like weight, height, GPA. Things like your weight and your height, for example, can be divided up into the ounces or the inches that fall in between those bigger numbers. So for example, someone could weigh 121.5 or 121.2. And so because you have all of those values within that interval, this would be considered a continuous variable. Oftentimes, when we're discussing data, we use the term distribution. So what exactly are we referring to when we talk about a distribution? So distribution refers to the values a variable takes and how often these values occur. For example, if again we were looking at our Columbus students and hair color, we might have our variable that said hair color, and then we would say we have, let's say, black, brunette, blonde, red, and then we could count how many had black, how many were brunette, how many were blonde, and how many were redheads. And this would give us the distribution. It tells us what the possible outcomes are, as well as the number of times that this happens. So when we're looking at exploring data, which is what we're going to spend a good amount of time doing, how do we approach trying to explore the set of data? So when exploring data, what we should do is start by looking at each variable by itself. Then we would move on to looking at relationships between variables. Sorry, I gotta erase this over here a little bit. And then we could start looking at graphing and moving on to numerical summaries of these variables. So the whole purpose of all of this is that we want to eventually be able to work on inference. So what exactly is inference? Well, inference refers to the idea that we want to use data to draw conclusions that are beyond what we saw in front of us. So if I wanted to look at some of the students at Columbus and then collect information on their hair color, I would hope that I could learn something about the bigger group of Columbus students and their hair color simply by thinking about the set of data that I have in front of me. Okay, so inferring something about a larger group based on the information that you have in front of you, based on the data that you first came up with, okay? So that's pretty much what we needed to go over in terms of our introduction. So we'll go ahead and move on to the beginning of section 1.1. So in section 1.1, what we're focused on is analyzing categorical data. So again, remember, categorical data is values that fall into a category, usually not number values, usually labels, things that would divide up individuals into categories. So when we're looking at our categorical data, oftentimes it's easier to take the data and collect it into a table to represent the important information. So there are usually two tables that we look at, one which is called a frequency table and one a relative frequency table. So what's the difference between the two? A frequency table is going to show you the number of individuals having each value of a variable. On the other hand, a relative frequency table is going to show you the proportion of or percent of individuals having each value of a variable. The difference is, by looking at the proportion and percent, you're looking at that group relative to the entire set of individuals. So for example, if I did hair color and we did a frequency table, we would give our options. So remember, we said black, brunette, blonde, let me write that out better, and then red. And then we could have our frequency. So let's say we had 10, 10, 10, and 10, for the sake of making this easier. Okay? Now, this is a frequency table because these are the actual values. If I wanted the relative frequency, I would have my hair color still the same, but my relative frequency is going to show me how it relates, how each of these categories relates to the whole. So this would be obviously 10 out of 40, or 1/4, and then you would have 10 out of 40 again. So this would be the difference between the two. Now these values could be written as 25%, they could be written as 0.25. Either way, anything that's showing you a relationship between the part and the whole, that would be considered a relative frequency table. Okay? Now, let me get these off of here. Sorry about that. So once we have the information organized in a table, we often want to create some sort of graphical display to help us visualize what it is that we're seeing. So there are basically two types of graphical displays that are appropriate for our categorical data. The first being a bar chart or a bar graph, and the second being a pie chart. So of course, a bar graph or a bar chart is going to show each category as one bar, and then the height of the bar is going to show you the frequency or the relative frequency. So for example, if I created a bar chart, let's say we had black, brunette, blonde, and then the redheads off to the edge. Each of these bars would represent one of those categories, and the height of the bar would tell us the frequency or how many times something fell into that category, okay? Now, a pie chart, of course, is used for something a little different. A pie chart is going to show how the category fits as a slice of the pie. So the areas, of course, are proportional to the category frequencies or relative frequencies. So a pie chart, I'm sure you guys are familiar with, but a pie chart would look something like this. You'd have your circle, right? And you'd have the black hair, the brown hair, the blondes, and then the redheads. And each of these slices would represent the proportion that they are of the whole group. So when it comes to creating these, what are some of the benefits and disadvantages of each of these graphs? So in terms of the bar graphs, they're relatively easy to create by hand. However, they don't do a good job of showing the relationship between the category and the whole. On the other hand, a pie chart is really great at displaying the relationship between each category and the whole. However, these graphs are much more complex to create, and therefore they're more difficult to create by hand. You would have to ensure that all the categories are also part of the whole in order to create a pie chart. So if you were missing some of the data, if you didn't have 100%, you would need to create a category for other. Part of the reason they're so difficult to create is that in order to be accurate, you have to have angle measurements that are proportional to the relative frequencies. So you would need your protractor, you would need to be measuring the angles in the circle, and it just gets really complicated to create by hand. Now, obviously, using technology, these are pretty easy to do. Both are pretty easy to do using technology. If you use something like a spreadsheet to create them, it would be easy to do. But since most of us are working by hand, typically, especially, on our AP exams, it's going to be really important that we stick mostly to the bar charts or bar graphs, but make sure that you're comfortable understanding a pie chart. The last thing I just want to address in this video is pictographs. So these pictographs are really pretty. They look beautiful. However, there is a little bit of a problem with these pictographs. So if you notice, for example, this image with the trash cans. The first trash can is 80 million, while the second trash can is only 160. So the size should only be doubled. However, because of the area that larger trash can is covering, it makes it seem like it's more than double. The same goes with these candy corns. If you look at the candy corn, this is about 18 for Shayna and about 36 for Michael. And yet the candy corn for Michael looks like it's more than double in its size, which creates the wrong impression. And so it's really important that we try to avoid these pictographs, as they're usually not the best display for our data. So hopefully you've been able to take these notes, and if you have any questions, please feel free to ask me tomorrow, and we can answer any of those questions in class tomorrow. Thanks.